Hello everybody, I'm Tom Clusard,
Hi, my name is John Costella.
and today we'll be teaching you about the ambiguous case. For today's agenda, we will talk to you about prior skills needed for basic knowledge of the ambiguous case, the single solution case, the no solution case, and the two solution case. We also provided 2 practice problems at the end to test our teaching ability and your knowledge. Now you may be asking yourself, what is the ambiguous case? Well, it is when there are situations where the information we are provided with for a triangle make it possible for there to be 2 different triangles created even after satisfying all the pieces of the given information. Before starting the lesson, we highly recommend knowing how to determine if a triangle exists and knowing different types of triangles such as obtuse and obtuse. Now, my partner John Costas will jump right into the lesson.
Hi, my name is John Costales, and today I will be talking to you about the law of sign and the ambiguous case. In previous units, we have learned how to solve triangles that have right angles. In this unit, we will be learning how to solve oblique triangles, which are triangles that contain only obtuse or acute angles. There are 4 different cases that can be used when solving for oblique triangles. The first case is angle side or angle side angle, and this is when the problem provides 2 angles and any given side on the triangle. The second case is known as side angle. This is when the problem provides 2 sides and an angle opposite to one of them. The third case is side. This is when the problem provides you with information on the 3 sides of the triangle. And the fourth case is side angle side, and this includes 2 sides and their including angles. It is very important to note that when using these cases to solve for oblique triangles, only the first 2 cases can use the law of sines. The second 2 cases require the law of cosines, which you will learn in a later unit. When solving for oblique triangles, it is important to have a firm understanding of the law of sines. The law of sines provides a ratio comparing the angle to its matching side. An example would be angle A over sine side A. This ratio stays consistent throughout the entire triangle. For example, if I took angle A divided by sine of side A and compared it to angle B divided by the sine of side B, they would be exactly the same. This is also true if I compared angle C divided by sine of side C to either of the 2 previous examples. The law of sines can also be represented in its reciprocal form. So if we were using the same example that I previously mentioned, we would say that angle A divided by sine of side A is our ratio. Now, this ratio can be flipped around to sine of side A over angle A, and they will give you the same answer. When solving for the first case, which is angle side, some important things to remember are that when you first get the triangle and are looking at it, it is important to identify what the problem has given you. This means clearly identifying which angles and which sides the problem has provided, and in turn, which sides you will be solving for.
Now, after learning the single solution case, there are still 2 more cases, the no solution case and the two solution case. Let's first start off with the no solution case. Okay, so let's say for the no solution case, it gives you A equals 15, B equals 25, and A equals 85. So it won't give you triangles, so you're going to want to, I already did it, but you want to make your triangle. You can put B here and C there. Either way, it doesn't really matter. And then after you create your triangle, you want to use the law of sines. Now with your law of sines, you're going to get 15, which is your A, over sine of 85, which is your degree, equals 25, which is your B, over sine of B. Then cross multiply, so sine of B equals 25 times sine 85 over 15. So after plugging this into your calculator, you'll get sine b equals 1.6603. So after getting this, you're going to need to take the inverse to evaluate for the angle. So this is what it's going to look like. B equals sine inverse of 1.6603. The domain must be between -1 and 1. But for the inverse sine of 1.6603, it is greater than 1. Therefore, this triangle is in the no solution case. So now we're going to do the two solution case. So over here, A is 58 degrees, B is 12.8 feet, and A is 11.4 feet. So it doesn't really matter where you put your A, B, and C, but I'm just going to put them up here. So we know that A is going to be 58 degrees. And then the lowercase a, it's always going to be adjacent from the uppercase a. So this, 1.4 feet. And same with this B, it's going to be adjacent. So 12.8 feet. So after you draw your triangle, you want to use your law of sines and get 11.4 over sine of 58 degrees equals 12.8 over sine B. Then down below, sine B equals, you're going to want to cross multiply, so 12.8 times sine of 58 over 11.4. Okay, so when you plug this into your calculator, you're going to get 0.9522. And after, you're going to take the sine inverse of this, so it's going to be sine -1, then in parentheses 0.9522, and that's going to be B equals 72.21. So after getting this value, you need to get another possible value for B. So in order to do that, you do 180 degrees, because that's how many degrees are in the triangle, minus 72.21, and you're going to get 107.79. So these are your two possible values for B. So it doesn't matter what case number you assign to each of the degrees, but I just did like this way. So now that you have two possible solutions for B, you're going to try and get C. So you're going to want to use the 180 degrees from the triangle, minus 58 degrees, which is A, and then minus the new degree that we got, which is 72.21 degrees. So for this case, case 1, we have it is set 49.79 equals C. So in case 2, you're going to do the same thing as you did in case 1. You're going to get the 180 degrees minus the 58 degrees, which is A, and minus the other B you have, which is 102.79 degrees. And then this is going to equal 14.21 degrees for C in case 2. So after you have your two answers for C, you're going to use your law of sines again. So you're going to do 11.4 over sine of 58 equals C over sine of 49.79. And after you put that in your calculator, you're going to get C equals 10.26. So that's your answer for case 1. And then you're going to do the same thing for case 2, 11.4 over sine of 58 equals C over the sine of 14.21. And you're going to get C equals 3.29, which is going to be your answer for case 2. So now after watching our lessons, let's get into some practice problems to see what you've learned. Okay, so let's say is B is 74 degrees, B is 12 feet, and C is 30 feet. So just next step is to draw your triangle. And you can put A, B, or C any way you like, it doesn't really matter. But make sure that B across from it, the lower, it must be across from it. So we know this is 12 feet. We know that B is going to be 74 degrees. Then C, you know that across, it'll be 30 feet. So next, you can draw your imaginary line, and you can call it H. And now we're going to solve. So if I'm looking at just this, it's a right triangle. So do sine equals 74 over the opposite and the hypotenuse, which would be H over 30. Now to solve this, you'll do 30 equals sine 74 degrees equals H. So after plugging this into your calculator, you'll get 28.84 feet. Then bring down your H. So in our case, there's three things that could be. H is greater than 12, H is equal to 12, or H is less than 12. So in our case, it's going to be H is greater than 12. So what this means is it's about 29 feet to get down to the ground. So you can look at your 12 feet and think to yourself, will the 12-foot board reach if you were to put it down? And it would be no. So it would be no triangles possible.
Now I'm going to go over an example problem of angle, side. So the problem tells us that angle C is 102 degrees, angle B is 29 degrees, and side B is 28 feet. So with the information given by the problem, we can clearly identify that we need to solve for angle A. We can do this by subtracting angles B and C from 180 degrees because all triangles add up to 180. In our example, this would equal 180 degrees minus 29 degrees minus 102 degrees leaves you with 49 degrees. This is the angles. This is the measurement for angle A. Now that we have all the angles of the triangle, we're able to use the information we have to solve for sides A and side C. So we know both the side and the angle measurement for B. So we are going to use B and apply it to the law of cosine. So when solving for side A, we would use the fraction 28 feet divided by the sine of 29 degrees because this is side length B over the sine of angle B, and we would multiply that by the sine of 49 degrees, which is the sine of angle A. This will give us 43.59 feet, which is the side length for angle A. In order to solve for side length C, we simply just repeat the same process by using the ratio side B over the sine of angle B times the sine of C. So this equals 28 over sine of 29 times the sine of 102. This leaves us with 56.49 feet, and that is the measurement for side C.